Okay, so let's start with this. So I am Guillermo. I am one of the developers in the VAELSYS V4 lineup of products. And I am sure that I have written down emails with almost everybody in the room, so you may also know me. And I think let's go and let's start. I will um, I will center the presentation in the new solution, the deep wall, the deep learning solution, because every thing we could discuss here will be also almost applicable to the other before solutions. I am sure you already know. So let's center in this new one just to transmit as much of new information as we could to you. And if you want to maybe know the differences between one of or the other, just if you have any question, I will be glad to answer it. So let's start. You should be now. I have shared my screen. Yes, I have shared my screen. So we will start with the V4 basics, and then we will talk about the initial configuration, and then we will be talking about the action protocols and programming. This is how the system acts when something happens, when something is detected. And then we will talk a bit more in depth about analytic settings. So let's start with the basics. I will pass a little faster in this step of the presentation. But as I have said, if you have any question, just answer, and I will. I just ask, and I will answer. Sorry. So this is the hardware we have for the deep wall solution. We have two different hardwares. The first one is the compact, is the one you can see on the right, and this very rugged system, very sturdy, and we could configure up to 8 channels. And this kind of hardware is designed for installations where consumption and science factors are really important. Also, this hardware, the compact one, it has no moving parts. So if you have any special environments in which this thing could be useful, I really recommend the compact one. And then we have the other is installed in a rack mounted unit. We could configure up to 12 channels. And in this case, I think the most important thing about this system is the density of channels, because you could configure up to 12 channels in one U. So performance and efficiency is the thing for choosing the rack mounted unit. Just take into account that the rack mounted unit is a bit noisy. So maybe if it is installed in the same room that people are working, maybe is a bit noisy to be in that situation. Is the thing that everybody tell us when rack mounted systems are mounted in the same room than other people. So it's really important also to talk about the software we install in our systems, because I think it's a great selling point. Because we are Linux based, we maintain our own modified Linux distribution. So we have all the usual advantages of Linux. The sturdiness, the safety is a very great point. Also the reliability, because as you may know, almost every big organization have the the background of the organization is built over Linux. So I think if big companies also choose Linux to build the companies from ground up, I think it's a very, very good solution and a very, very good selling point also. And of course, efficiency. All the systems based on Windows are they don't have the full control of the hardware as we have. So we could squeeze all the power of the system just to run as much video channels as we could. So this also help us with the density I talked in the last slide. Okay, so more advantages of using this kind of software is maybe these are also big selling points. You only need a web browser to access the system and to configure it. If you want, you could also access via a keyboard and a screen. But we think that accessing using only a web browser and not Internet Explorer, just Firefox or Google Chrome in the latest versions, we think that is a very, very useful advantage. You also don't need to install any ActiveX. You don't need to install nothing. Just to access the system, as I have said, you only need a browser. We do not install remote access programs because we think that maybe they could be a hole in the security of the system. But if you need to, we could install them, but only if you request us to do so. And you could configure the IP and the connection ports for each of these systems. And also, in the case of this specific hardware, the rugged one and the rack mounted units, both of them has two network plugs. So you could be in two networks at the same time. The only limitation is the gateway can be only configured in one of them. So you, for example, could have one network 40 cameras and the other to get out to the internet, for example, or accessing the unit from another network. And if this is the hardware we have for the DeepWall systems, if you are interested in the hardware we have for the other technologies, this hardware is different. We have a rack mounted unit and a compact unit, but the compact unit is different. So if you are interested in that, I could share more information after the presentation, just for you to have. So we are centering the talk, as we have said, into the DeepWall technology. So those are the distances, theoretical, and for detecting a person of 1.5 meters in height. I'm not going to give it a lot of importance this, because we after the presentation I will share with you a full table with all this information that is very useful, but I think having it written in a table is it's better for you to use the information. So let's talk what are the differences between this system and other deep learning based technology, because as you know, deep learning technology is on the rise. A lot of cameras and a lot of recorders have some kind of deep learning detection. So what's the difference between this kind of detection and the detection we perform in our systems? So uh, as you may know, deep learning is also very dependent on the model training. So if you have a very good quality training, the detection will be also a very good quality one. Other thing we are working on is that traditionally deep learning systems are not designed for perimeter security. For example, we all have seen, for example, I don't know if we have, then we will talk more about this in depth in the along the presentation. But for example, deep learning systems are designed to, for example, detect boxes, detect vehicles, detect people, but they are easily fooled when, for example, people are behind objects or have umbrellas or boxes. So this is why we say that they are not designed for perimeter security, because they are easily fooled if the person is disguised with this kind of objects. So we have developed 5 technologies associated with DeepWall that help us to avoid these kind of situations. The first one is WallNet, that is our neural system specialized in perimeter detection. So we have specially trained our deep learning system to be specialized in perimeter protection. So the next one is a smart zone. It, in my opinion, this is the best one of the 5. We will then, during the presentation, talk a bit more about that. But I think it's really, really interesting. And this smart zone is a system that intelligently adapts video analytics behavior to the activity of the scene. So if we, for example, are detecting continuously a false alarm in the scene, smart zone will adapt video analytics behavior to stop detecting this false alarm and not flood the ARC feed of video. So people in ARC will not discard the full site because they are being flooded with a lot of detections, false detections. So we thought that is easier for the ARC to detect, to have less alarms in this kind of situations, just to avoid the discard of the full site. So the next technology is wave cancel. We have specially designed this algorithm to avoid activations caused by vegetation. We will also talk a little bit more about that. This is the algorithm is based on the movement and displacement difference, because when vegetations cause false activations, it's because they are moving. They are not displacing or displacing through the scene. So we use this situation to distinguish between vegetation and possible suspicious objects. So the next one is autoscale. This is an application for adjustment of perspective, because as you may know, our systems are based in the size of the object in pixels. So, as you may know also, a person is not as big in the foreplane that in the backplane. So we need some technology to adjust and calculate the apparent size of an object in the whole scene from foreground to background in every step, just to detect this object better. And of course, we also have Dynalight, which is a patented technology to avoid light changes and prevent false activations cause for example, these kind of shadows and sudden light changes that may occur in the scene. So let's talk about a little bit more about Walnet, because this is really interesting. We have defined 4 different categories for the objects we could detect on this scene. And we have vehicle, person, suspicious object, and not suspicious object. This is really interesting because most deep learning systems that are already built-in cameras and recorders, they just detect, they are searching for a person or searching for a vehicle. But if this person or this vehicle is behind an object or disguised in any manner, they will not see a person, so they will not report this incident. So we have decided that this product is also designed to be used as a perimeter detection. So we need to distinguish between suspicious and not suspicious object when we detect an object that we are not sure what it is. We are going to talk more about that during the presentation, but it's really interesting. If we detect something that we are not sure what it is, we are not sure if it's a vehicle, we are not sure if it's a person, we will say that it's a suspicious object, and we will maybe report it to the ARC. And if we are sure that this object is a dog or is a rock or is a shadow, we will label it as not suspicious, and we will not report it to the ARC, for example. Also, Walnet, our training for the deep learning system, is prepared to work in long distances. There is no issue in thermal operation, and we will send also these categories, vehicle, person, suspicious, and not suspicious, to the ARC. So they in the ARC, where they are watching all the events reported from the system, they will also see what category of the what is the category of the event, so they could also filter by category if they want to. So, for example, as you can see in the image on the left, you can see a dog. So the system has recognized that this object is a dog, so it is labeled as not suspicious, and the person in the foreground is detected as a person, so is labeled as P person. In the image on the right, you could also see the same behavior. On long distances, we have detected a person, so we are sure that this object is a person, so we labeled it as P person. Okay, so this is a okay, so as you can see, we have detected 2 objects in this. You could also access this video if you want it. If it's useful for you, I will also share it with you. And as you can see, we have detected 2 objects. One is a shadow, and one is a person. Yeah.
Can I ask you something?
Okay, I think it's. Yeah.
Hello?
Okay. Yeah, I can hear you. Sorry.
Yeah, I have a question.
Yeah, ask it.
In all the DeepWall products, there is standard, Walnut, and all the other versions.
Yeah, it's something built into the DeepWall algorithm. So if you have a DeepWall license built in a system, you will have all these features.
Oh, okay. So you have to select then Walnut, for example.
No, you don't need select that. Let me also show it to you. This is the configuration of a DeepWall channel. I will also talk about this in depth through the presentation, but as you can see, we have a DeepWall channel configured there. So if I go to analysis and try to, for example, edit one rule, as you can see, you can select if you want wave cancel or not, if you want SmartZone or not, because I am going to explain wave cancel and SmartZone in depth then. But Walnet, as you can see, you cannot select it because Walnet is built in the DeepWall engine.
Okay. Thank you.
Okay, so let's come back to the. Okay, so as you can see, we detected two objects. We are not sure what this object in the ground is, so we are labeling it as suspicious, and we already know what is the other object. It's a person, so we labeled it as a person. As you can see, when the person goes out of the zone, it gets not detected. In this case, we are detecting a vehicle and a person, suspicious, and then it could be labeled as a person. It first got labeled as suspicious because the system didn't have all the information. So just to be sure, first it detected the person as suspicious, and then when all the information arrived and the system was sure that the object was a person, it relabeled it as a person, and the next detection, all the information was there, so the system labeled it as a person from the start of the detection. Let me also, and this is what I was talking about later. As you can see in the left, we are searching for different objects, in this case car, in this case also motorbike. But if someone appears disguised in a box, the main deep learning system will see a box and will do nothing, or will not recognize the object, because the system will not be trained to search for boxes in the scene. So as we see an object and we don't know what it is, we labeled it as suspicious and the event will be reported. I think this scene worth it, that we go with the box in the head and that kind of things, because I think this scene is very illustrative of the main problem other deep learning system has, that they do not report the objects that they are not searching for, or they are not sure about what they are. So this is a big selling point of um, the new DeepWall technology. We have also another example with the umbrella, and as you can see, we trained our model very well, because I am in this scene disguised with an umbrella, and the system also labels me as a person. So the system knows I am a person behind the umbrella. In the start, I think I got labeled as suspicious as I was going out my cover, suspicious, and then person. So in this case, person is not configured to be sent to the CRA to be reported. As you can see, if the line is blue, the event means that the event was not reported, and if the line is red, the event, it means that the event got reported. So in this case, as you can see, you could configure the system to report only suspicious objects or only person and vehicles? I will also talk about in this specific slide. As you can see, Walnet has 3 alarm levels. Red level, people and or vehicles, as well as any element, suspicious or not, will be reported. If you configure the zone in yellow level, people and or vehicles and any suspicious element will be reported. This means only not suspicious objects will not be reported. And if you configure the system in green level, only people and or vehicles will be reported. So nor suspicious nor not suspicious objects will be reported. The important thing about these 3 alarm levels is that these levels can be configured in a zone basis. Not in a zone basis, but in a rule basis. So, for example, in this zone I have marked as green, we have configured only yellow alarm. But, for example, on the red zone, we could have configured red alert. So we could configure different alert levels for different zones on the scene. So we could define uh, zones that are more critical than others. And as I will demonstrate later, our philosophy when designing this tool is giving you all the configuration options that we have, because we want a system. We want the system to um, adapt to every scene we could. So maybe this system is a bit more difficult to configure than others, and is a bit more time consuming, but is very, very powerful. And we want to ensure that you always have something to change, or you always have the right tools to make the job, and you will never get you will always have all the tools needed for a difficult scene to be managed. I don't know if I am explaining correctly, because my English is a bit rusted, but this is the philosophy of the system. We will give you all the tools we need, and just for you to use them. Okay, so this is the big selling point of Walnet, I think. The 3 alarm levels, and the fact that you can configure these levels in a rule basis, all in the same scene. Okay, so this is a bit of a resume of the thing I have explained. If you have green alarm, on a person and vehicles will be reported. In yellow level, unknown, suspicious, and person and vehicles will be reported. And in red, every object detected will be reported. Of course, not only the object and the behavior matters. Also, you have a minimum size filter for the objects. I will also talk about that. Okay, so let's continue. The next is, as I have said, Smart Zone. Smart Zone will check the behavior of the analytics and avoid repetitive situations. For example, in this case, in the image on the left, we had a branch of this tree continuously moving due to the wind. So as the system detected that a false alarm is getting triggered every few seconds, the system modified the behavior of the engine to make to avoid this situation. Also, this can be, for example, in this case, this is spider web in front of the camera. So Smart Zone also detected that this is a false alarm currently triggering every few seconds. So it will modify the behavior of the AI to avoid this detection. And if, for example, a person comes into the scene, this detection will not be compromised. Of course, there is, for example, let's imagine this green zone is a very, very critical zone, and we want to report everything that happens on this extremely critical zone, green zone. So I could disable Smart Zone if I want. As I have said, our philosophy is giving you all the tools we have just to accommodate every situation you could also have. So if you have a very, very critical situation in which you don't want the system to automatically um, modify the behavior of the system, you could disable it if you want. This is more or less the expected performance of the system. These numbers are really useful when you go out to sell this solution. So I will also share them with you at the end of the presentation. So I think if you have any question about this overall of the technology we have just made, it would be great if you could make it now, and we will continue to an example of an initial configuration of the system. Okay, let me check the chat just in case. Okay, there's no questions about that.
No, just a thing, Guillermo.
Yeah,
You were seeing some visual cameras. With the thermal is the same thing, that we have the same situation. The
yeah.
the 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 bit the rate of alarms is bigger, lower. Do you recommend to use visual or thermal on
We could
this
use
with deep wall?
whatever you want because, of course, in thermal imaging, we work the same way in visual and thermal imaging. So the system will work the same way, and the rates will be more or less similar. Of course, in thermal imaging, it's easier to detect people because the contrast is really, really good, and we have more information to distinguish an object from the background. So the rates will be better. Of course, thermal cameras are more expensive than visual ones. So you could use whatever you want or whatever it suits to your project in terms of price and performance.
Okay, so visual or thermal you can use in deep wall without any kind of problems. Okay, perfect.
Yeah,
Thanks.
the license is the same. So if
Okay,
you
same
and
license.
also, yeah, the license is exactly the same, and you could also mix thermal imaging and visual in the same hardware if you want to.
Okay, so I do a question to you. Let's see. Imagine that
Yeah.
I have a dual camera. Okay, and on
Mhm.
one side I have the visual side, and on the other side I have the thermal side. So I can get the two streams and tell and do a rule that say that both of the streams must have an alarm to be a specific alarm. I mean, imagine I have the visual camera, I have the thermal,
Mhm.
and I can make a rule that says that I use the visual and the thermal to make an alarm. I need the signal of both streams of the same
This
camera I'm talking
currently,
about.
yeah, I understand. It is currently not possible per se. You could, for example, use the thermal site to detect and then send to the ARC both images, for example.
Okay, right.
But currently, it's not possible to make a rule that both of thermal side and visible side needs to trigger the alarm
Yes. The idea is
report it to the ERC.
was to wear it or to use it as a cross zone, you know, that you need a confirmation of another camera to tell to this first one, to the first alarm, that it's really alarm, that you need that kind of confirmation of two cameras, for example.
You could maybe configure something like that in the same camera, because you could define two zones in the camera and define a rule in the way that only when an object stays in one zone for 2 seconds and then goes to
Okay.
the other, you could also configure something like that, but always inside the same scene.
Okay, I understand. Okay, configure the rules, but with the zones. Okay, perfect.
Yeah, and also if you could use a visible site to just to facilitate the work of the ARC, detect with thermal site and send both sites to the ARC, you could also do that, because we have a special license. We call it evidence channel. So the evidence channel only records the scene when other camera has reported a detection. So
Okay.
then the video is mixed and sent to the ERC, both cameras. So I think this could be also useful, and is a very good solution if you have dual side cameras.
Okay, perfect. Thanks, Guillermo.
Okay, so I don't know if
Another
anyone
question.
has any other question.
Yes. Uh,
Hi,
you are
Just.
saying that the system is the system working with the same quality by night with a thermal camera or with a IP starlight? I think it's better to
Yeah,
use than a thermal.
I am not an expert in cameras, so
Okay.
I don't know if starlight cameras will make a difference. But I think that the important thing is the quality of the scene, the information we have to distinguish the object between the object and the background. So starlight cameras, as I think I know, are very good at night. So I think it would mm, possibly make a difference, but
Okay.
I think we will need to test them. But if the object is distinguishable from the background, it will work. Yeah. So it seems that there are no more questions. So let's continue with initial configuration. Okay. So I think I will do it directly in the system, because I think it's better for us. Okay. So let's log out. This is the main login page from the system, and I have prepared a user in English. By default, the system is configured in one IP and with the username admin without this, and the password is 1 to 6. But the default in this system, the default user is in Spanish, so I have prepared this special one in English. So we log in into the system, and first we will check the configuration, because I think there is important to know some things that are important to know. The first one is the network. So in this case, we only have one interface, but as I have said, in the case of DeepWall hardware, both the compact and the rack-mounted unit has two Ethernet interfaces. So as you can see, you could here configure an IP, a mask, a secondary IP, a secondary mask, a gateway, the DNS, and it would be also some information about what is connected to the interfaces. And you could, if the hardware supported, you also have wireless communication. And we also recommend you to configure a fixed IP for the system. As I have already said, the only restriction here, if you have multiple interfaces configured, is that the gateway can be only configured in one of them, because in other way the system will not find a way to go out to the internet. And the other thing I want to discuss about the configuration is the support. Okay, so support. This is really important because, as you may know, one of the difficult bits of configuring a system is how I can help you configuring a system if I cannot access it. So to avoid opening ports, we have developed a support connection that if you ask us for a password, you could enter the password, create a support connection, and this will contact, if the system on site has access to the internet, it will contact in between system and open a port that is open in the internet this way. So we could enter to help you out with the configuration of the system without the need of opening ports on the router, what is really useful. You could also create a technical support user. This is a randomly generated user we could also use to help you to configure the system without the need of sharing with us the admin credentials of the system. As you can see, with these two bits of information, I could access the system with no problems and help you out with the installation of or with the configuration of the system without the need of any other configuration in the network. So I think they are very interesting. And of course, when the intervention is over, you could disable the user, close the connection, and I have no access to the system anymore. Okay, so what is also configurable from this from this tab? In this tab, you could give the system the information about any other device that could be connected to the system. For example, if you want to send emails, because the system could send you an email if you configure it to do so, it could need TLS server to do so. So in the email tab, we could configure the TLS server. If you want the system to send the images or the video to an FTP, we will need to know where the FTP is. If you need the system to move PTZ camera, we will need to know where the PTZ is, what type is, the username, the password, and the more important, for example, if you want the system to report the events to an ARC, we need to know the client ID, where the ARC is. So in this tab, we will need to configure all the information the system needs to interact with other systems. Maybe the most important one is the I/O devices. As you may know, we have integrated several devices that could, for example, have relay control if we can open or close a relay if something happens. So we are compatible with Modbus devices. They are Ethernet compatible relay boxes. They are also very good quality ones. You could also use Dahua or Hikvision Hyundai systems that has outputs. Yeah, so we can trigger those outputs if something happens in the system. And we also have USB modules. If you are interested in more information about these devices, I could also share them with you at the end of the presentation. Okay, so as you can see, you could interact with a lot of systems. So we have a very interesting philosophy on how to configure these interactions. When something happens in the system, something is detected, for example, or maybe an input IO input is triggered, or maybe a signal is lost. This system will give you the option to configure a actuation protocol. This actuation protocol is the instructions that the system will perform if this event triggers. So these actuation protocols is what we call system alerts. For example, let's configure one of them. Alert, for example, let's imagine we want to send an email if something happens. For example, if something is detected. So we could define a protocol, an actuation protocol called send email. Okay, so we could, where is send email? We have, okay, send email. So we can add an action. The protocol, in this case, the system alert, it's just a name of a list of things that the system will perform, a list of actions that the system will perform if the event associated with this configuration, with this alert, is triggered. So we want, as you may know, we also have a lot of possible actions to perform. But the important one is we want to send an email. Where is email? So email, we want to send an email to, for example, this subject alarm, an attachment image, for example. Yeah, the system is warning me that I have not given the information to send email, but let's ignore it for the moment. So we could define as many of these actuation protocols as we want. For example, if I want to report the, let's use this created one, send email. So let's make a configuration and use this actuation protocol to report the events. So once we have talked about um, how to give the system the information of the devices or services the system will interact with, and the way of defining how the system will behave when something happens, the next step is configuring the system to search for the objects and configure the scenes. And to do so, the first step is giving the system the information about the video channels it needs to process. So as you can see in the screen right now, you could mix different engines in the same hardware. This is really a very good selling point of our system, because all the philosophy and all the internal workings that I am going to show you are almost the same regardless the engine we are using. So if you learn how to configure a DeepWall system, you are also learning how to configure detect and tracking, what is the perimeter detection technology that do not uses deep learning. And you will also be learning how to use LPR or facial recognition or any other engine of the V4 family, because they all share the same web interface and they all share the same philosophy of working. So let's add a new channel and start configuring a new scene. So to do so is really easy. We need just to click on a channel, and the system will ask us for a name for the channel. We also recommend to always configure meaning names for the channels, because these names are then reported with the event, and this really helps people that are watching the events to distinguish the zone and what is happening. So we always recommend to configure meaning names for that. So for example, name, we could entry, for example. Then we will need to to introduce the IP address of the device. We are both compatible with DVRs and cameras. I will also demonstrate it. So for example, I think this is one. The port we need to configure is the Rtsp port, because we are compatible with any camera that is a camera or device that is capable of sharing the video, streaming the video using Rtsp. That is a standard protocol. So the default port for Rtsp is the this one 554. So we will need also to give the system the user and the password for the device, and also we could select the type. If we are connecting a camera or a DVR, we have pre-configured a fixed database that will make the addition of the channel easier, because you will also need to select the type, camera, for example. Let's Dahua, for example. Dahua is here. And in the option, we could select primary or secondary stream, and the RTSP path will be automatically connected. Let's imagine we have a different camera that is not in this built-in database. Okay, we could set it to manual and change the RTSP path as we want. Okay, so we also recommend you to almost always use the secondary stream, because the mainstream is useful to be sent to a recording, to a DVR, or any kind of recording device. Because as you have said, our systems are designed to be a event-based system. So we record, but we record events. The system is not designed to be continuously recording. We could do that, but we reserve this functionality to, for example, maybe help you in a situation in which some objects are not being detected and you are having some trouble with detection. So we could record continuously this scene just to help you to resolve the situation and to get why the system is not detecting properly. but is something that we do not recommend to use in a daily basis, because some other devices like DVRs or NVRs will record continuously uh, a lot better than us, because they are designed to do so and we're not. So we always recommend to use the secondary stream, because we also need a particular resolution to work with. In the case of DeepWall, is 4 CIF, 4 CIF, the proper resolution, I think. I will also confirm the resolutions for every one of the engines in the V4 family after the presentation. And it's really important to give the system the proper resolution to work with, because if we don't do so, the system will need to adjust this resolution, and it could use some of the performance that the system has to do so. So we have dimensioned the system to take this into account, but a camera or a DVR will adjust the resolution much better than we do. So it's always recommended to configure the secondary stream to the proper resolution of the analysis, and then configure this secondary stream as a video source in our system. I say the secondary stream because the primary stream is usually used to give video to the DVR and continuously record the scene at the highest quality possible. So this is the more or less the usual configuration, video configuration between a DVR, our system, and the cameras. We are in this case asking the video to the camera, but this will cause that two complete video streams are going through the cable that connects the camera with the switch or the router in which we are connected. So maybe it could be a better idea to ask the video to the DVR. This way, the camera will send the video to the DVR. The DVR will convert a secondary stream of this camera into a usable resolution for us, and then it will share the video with us locally. So the cable between the DVR or the switch and the camera will not need to transmit two streams, but only one. So we could, for example, ask the DVR, the secondary stream, and the channel 1, 2, 3, 4, or the channel we need to get from this DVR. So the usual configuration, I have no DVR in this IP, so it's an error. And if you get an error, you could go to details, and the system will give you information about the details. This is always useful to debug possible connectivity issues between the system and the device we are getting the video from. So the usual configuration is a camera send video to a DVR. The DVR is continuously recording the primary stream at the highest quality possible, and then the DVR has configured, we have configured in the DVR a secondary stream with the proper resolution for the detection, and the system will ask using Rtsp to the NVR or DVR the video from the cameras in the correct resolution. So this will, when a channel is added to the system, it will create a row in this in this channel table. And as you can see, we have a lot of buttons to play with. This first button is the state one. If the state is blue, it means that the system is not getting video from this source. And if the button is green, it means that we are receiving video from this source. It's important to say that receive video doesn't mean that we are processing this video. So we are now receiving video, but not processing it. If we want to process it, we will need to activate the detection. So if the detect button is green, we are currently detecting. And if it's blue, the system will not process this video feed, and no events, no objects will be detected. But the question at this point is always, what's the difference between having if we retrieve the video but we are not detecting it, what kind of events will we be getting in this case? So the only events will be reported are, for example, network failures and network recoveries from this video source will be reported if state is activated but the detection is not. We could also record continuously, as I have said, but this is not recommended. We can do that, but it's strongly recommended that the continuous recording is made in other device, specially designed to do so. So more or less, this is the way of getting the video feed to the system. So let's configure this. Of course, if we try to edit an activated channel, the system will not let us change anything. We need to first stop the channel, and then we can edit all the things. You could also, when the system is receiving video, you could also click in the name, and a little viewfinder will pop up, and you could see the real time of this video source. Okay, so let's talk about how to configure a system. Let me also zoom in a little bit. Okay, so I will erase all the information, all the zones we have already configured, and start over again just to explain you how it's done. Okay, perfect. Okay, so the main okay, the dependencies deleted. Okay, so the main object when configuring perimeter detection, this procedure is very similar in any other engine in the V4 family. The main object here is the zone. Every configuration is built around zones. Okay, so the zones are just zones in the scene. So, for example, the first step in approaching a configuration is thinking what I want to detect in this scene. So let's first think what we want to detect. So I'm going to configure this scene in this way. I am going to define a zone in the background in which I will only report objects, vehicles, and people. And then I will define a more critical zone in the foreground in which I will report everything that enters that zone. So as you can see, in order to define a zone, I will only need to click into the image. One click will result in one red dot. The red dots can be moved, and I don't think that this is very. I don't think, no, it's not showing very well. But when I click on create zone, the last 2 points will get united just to create the zone, for example. So I define a zone, I create the zone, and the zone will be created. The system will also recommend me to add a rule, because I will click on yes and click on submit. I will explain this in depth a bit later. So, as I have said, the zone is just this group of points and lines over the image. If I can edit it, if I click on edit, as you can see, this is just a color, and the color, it doesn't matters what color is it in the detection. The only thing that matters is the shape of the zone. So, for example, this far zone. So the color, I could change it if, for example, we are configuring a 12-month side camera. Black and white, they are not a very good color. Just to show, this is only user experience. There is no meaning in this for the detection. So as you can see in the zone, there is no more configuration. It's just the geometry of the zone. So for a zone to properly work, we need to define a rule, and the rule is the characteristics of an object that an object needs to meet to be reported as an event when this object enters the zone. So in this case, as I have said, we always recommend to define meaningful names. So in this case, var zone rule. So let's put rule 1. Okay, so let's talk about every configuration we could define in our rule. We have, first of all, as I have said, you can disable wave cancel and smart zone. Just to refresh, uh, 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 wave cancel. Smart zone is the engine that automatically modifies the behavior of the IA to avoid false activations, and the uh, uh, and the wave cancel is the technology that help us to avoid false activations due to vegetation. So you could disable them if you want. We always recommend getting those checked. Maybe a smart zone can be disabled in a very, very critical zone, as I have just explained. And the other useful configuration in this set is the minimum size. The minimum size is the minimum size an object needs to be just to trigger a detection. So as you may ask, a person, an object, is not as big in the foreground that in the background. So we could also activate a fob lane, a different set of minimum sizes. So these sizes represent, these boxes represent these sizes we have defined here. We can see with 20, yeah, but these 20 are pixels, and calculating pixels with real life people on site is difficult. So we have decided to use this kind of boxes. As you can see, as I move the box, the the sizes change. So we could put someone there and calibrate the minimum sizes just to better distinguish the proper size of an object, the proper minimum size of an object. This kind of configuration help us to avoid, for example, shadows and that kind of things. So we always recommend to set the sizes a little smaller than a person in width and a little smaller than the half of the person in height. And of course, this set of sizes will refer to an object in the start, in the foreground of the zone, not the scene of the zone. And the far plane will refer to the size of an object on the far plane of the zone, and the system with these 2 points will calculate the proper minimum size of an object from from this perspective in all the zone. It's important to say that this size is calculated linearly. So, for example, if we have mountains here or that kind of things, you could also divide the zone in multiple zones to adjust with more sets of sizes. But this is the usual configuration for this kind of scenes. Okay, so the next thing we need to configure is the detection target. What we want to detect? We want to detect only people, or we want to detect people and cars. In this case, let's check people and cars. And the next step is defining the alarm mode. If we want red alert, yellow alert, or green alert. As I have said, Smart Zone could modify the alarm mode if this detects a lot of activity. So for example, we could set it to red alert, and Smart Zone will modify the behavior of the IA just to reduce the false activation rate. So in this case, I have said that I wanted to report only people and cars. So I am going to set it to yellow alarm because I want to report people, vehicles, and any suspicious item. So for example, a dog, if the system detects a dog and is very sure that this is a dog, it could be not reported. And the last and more critical configuration is the alert. So what I want the system to do if an object that complies with all this configuration enters this zone. So what I want to do is, for example, send an email. I have to just to refresh another another advantage of having this web-based configuration is that you could open more than one tab. So all system alerts can be configured from the configuration tab, and you could configure as many alerts as you want. And this alert sent email will have a list of actions. In this case, the list is only one action, that is send email to someone. But we could also, for example, add another action. Gateway before is the send the email to the or send the detection to an ARC. So we could, for example, attach a video or a video with evidence channel. This is what we were discussing earlier. If you have an evidence video attached, configured to a camera, it will be also sent to the ARC using the gateway. The gateway is a software we install in the ARCs to help them to receive events from our systems. So if you know an ARC that want to receive events from our systems, we will just get in contact with them and help them to install the gateway to receive our events and send them to the ARC software. We are compatible with Manitou, with SVN, with Mastermind, and I think with a couple more of ARC softwares. And we will install this gateway free of charge for them, just to prepare them to receive events from our systems. So we could also add a new action. So send email. We could send, for example, change the name. So send report alarm. So the alarm will be reported first, sending an email to this address, and then sending a notification through the gateway to the ARC. So if I come back here and go on submit and I edit this one, now the alert is report alarm. I could also select any other alert, but this is the one we want. Okay, so now if someone, a person or a vehicle or something suspicious um, goes in this zone, we will get an email and the ARC will be reported. And minimum time is maybe a bit low because this zone is very large. So we could, for example, put 4 seconds. So the object will need to stay more than 4 seconds in this zone to be reported. Okay, so let's configure another zone. I will click. Okay, clicked. So I will also create a zone. I will create a new rule, and I will submit because I want to change the zone name. This is here, zone. Okay, red is a very good color. So let's configure it. And now let's configure again the rule. Okay, so uh, near zone rule 1, I will, for example, configure minimum size. This configuration, I am going to do it fast, but in a real world scenario, we maybe want to go to tell a companion to go there. One thing, the scene you are seeing is a fixed image. If you want the video to appear, you need to click on continue and the video will appear. And for example, if your mate is in the scene, for you to calibrate the system, you could pause and the image will pause. So you could move the minimum size box near your mate and calibrate it with your mate. So it's easier for you to calibrate it. Minimum time, let's see, for example, 2 seconds. I will keep, we always recommend keeping wave cancel checked. Smart Zone, in this case, I want to maintain a higher level of security, so I will uncheck Smart Zone. I don't want the system to automatically adjust the behavior of the AI. Detection target, I will leave people and cars. Alarm mode, I will check red alert, people and or vehicles. everything will be reported, and I want the system to perform a report alarm. Okay, so as we configure, an email will be sent, and the event will be also sent to the IRC through the V4 gateway. As I have also said, everything is a possible triggering thing for an event. For example, if we have a signal loss, we could configure any action we have already configured. For example, let's say that let's imagine that I have also want to send an email if this camera loses the connectivity. So I will add a new alert, send email. This alert will only send the email. It will not be reported to the ERC. So send email, example, subject, and the attachment will be image in this case, for example. Okay, system is warning me that I have not configured the email server, but it's no problem. So if we have a signal loss, now I can send an email if I want. This is a very good situation to explain these two choices in the combo box that are not in this table. The default alert is in the table, but the other one is not. So default alert is the alert is configured by default in everything that can trigger an event. So this default alert does nothing. If I go here and click on default alert, as you can see, I can click in everyone, and the alert chart will show only the actions associated to every one of these actuation protocols, this alert. If I click on default alert, there is nothing. So if I select default alert, this event will be only recorded. No further action will be performed. So if I, for example, in signal alert for signal loss, in the case of a signal loss, if I configure default alert, this signal loss will be only recorded. In this case, we will record the 3 seconds prior of the signal loss. In the case of a recovery, we will record the 3 seconds after the recovery. And if we select without alarm and alerts, this event will not be recorded even. No further action will be performed at all. So this event will be completely ignored. This is useful for something that we are going to check later. So in this case, we will leave those as default alert. And this is a very good situation also to see how events are stored inside the system. They are in this tab, events tab. As you can see, the events are shown in a table. And if you click here, you can see the video, you can download it, and you can see the information and also thumbnails of the detection. In this case, you could also use the advanced search to define from and until timestamps. You could also filter for using event types, and you could also search for the actions taken when this event is triggered, and also using the camera. If I only want videos from one camera, I can select it, and only videos from those video source will be shown. If I could go back to to the simple search, I could also see that we have here a calendar, and if the number is orangish, you could click in it, and it means that in this day there are events that you could review. Okay, so coming back to the configuration, we have other processing options, and these processing options are applied to everything in the scene. As I have said, these configurations that pop up when I click on edit in a rule are only applied in this rule, what is associated with a zone. So these configurations will only apply to that zone and that rule. But there are some general processing options that applies to the entire scene, and we don't recommend changing that these configurations, because they are usually the default values are usually the correct ones for the vast majority of the scenes. The sensitivity is just the sensitivity of the system. The environmental learning is the speed in which the system will take the background as background, the changes in the scene as background. The depth of field is useful, maybe is one of the ones that get changed more usually when configuring different scenes, and this give information to the system about the depth of field of the scene. In this case, is set further because this is a very long scene. If we, for example, could have a camera just facing up a wall in a few meters, we will need to check and maybe to configure default or closer just to the system to perform better. The recognition confidence is the percentage of confidence that the system will need to have. For example, if detecting a person, just to say, yeah, I'm sure that this is a person. In this case, as this is an example, they have configured as 60%, but I think that the default value is a lot higher. And the sabotage threshold is something really interesting, because let's imagine that someone wants to break into your house and wants to blind the cameras by hitting them, or maybe down by using a spray can to paint the sensor, so you will not have a proper image of the scene. So in these both cases, just moving the side of the camera or painting with a can, in both situations, you will have a very large portion of the scene changed suddenly. So we call that sabotage. So if the sabotage threshold is of something that is very useful, and is the other, maybe the other configuration that is usually changed when configuring inside processing options. And this defines the percentage, the minimum percentage of this scene that needs to change to trigger an alert in case of sabotage. So in this case, 40% is a really, I think it's the default value. And it's a really good value from this, because if the camera got hit, or maybe someone changed the side of the camera, suddenly the sabotage will get triggered. And this is the alert in case of sabotage. So what we want the system to do if a sabotage is detected, as you may see, everything works the same way, and there is a lot of things that can trigger an event. You could also define in this configuration all the possible things that the system could do if something happens, and then you could also merge those both things, the trigger and the actuation. So when something happens, the system will behave in a certain way. So we could, for example, send an email, and only an email, if the sabotage threshold is triggered and a sabotage is triggered. Yeah. So we could also, for example, let's imagine that, for example, we have a camera, and a lot of trucks, very big trucks, pass from the camera, and they just get in the way of the camera, and they are continuously triggering sabotages because there is a big change of this on the scene in this particular case. So I want to avoid any sabotage triggering. So I could set the alert in case of sabotage to without alarm alerts, so the sabotage will be completely ignored if this occurs. And as I have said, the smart zone is the technology that changes the behavior of the AI when something happens. For example, if something is continuously triggering the system, the way that smart zones does that is, for example, if we have defined red alert and we have smart zone check, let me check it. Maybe the system will detect that a lot of false activations are being detected in a short period of time, so it will um, degrade the alarm mode to yellow to avoid that, or maybe it will degrade it to green, and then when the situation resolves, Smart Zone will automatically reconfigure the red alert, um, just to keep the configuration as a human like me um, configured it in the first time. But it's useful to know when Smart Zone wants to do that. When Smart Zone did this change in behavior. So you could configure an alert in the case of a filtered alarm, when a smart zone does this kind of change to filter an alarm. So you could, for example, send an email if you want, or as a default value, just ignore it. Okay, so let's get in depth in more things that you could do. For example, a zone could have more than one rule. For example, in the case of the green zone, we could add a new rule. For example, I could far zone, rule far zone, and I could, for example, wandering. So let's imagine I want to detect someone wandering. I will configure the minimum size. I will let the default values, but this is not a good practice. I will need to calibrate it, but I am going to do it um, a lot faster. So let's imagine that we want to send an email when someone enters the zone, but only report the ARC when the person or the vehicle stays for more than 45 seconds in the zone. For example, let's try to do this kind of configuration. So, for example, if someone enters and stays 1 second, I want to send an email. Okay. And everything, red alert, people, vehicles, suspicious, not suspicious, everything. People and cars. Okay, so let's do that. Okay, so far, no, this is the immediate one. Rule far zone, immediate. It will send an email when someone enters. Then we could edit the rule we already had, set it to red alert, for example, and set up 45 seconds and then report the alarm. This will configure something like, for example, if someone enters the zone and stays 1 second, this rule will get triggered and an email will be sent. If the person stays here for 45 seconds, then this rule will be triggered and an email will be sent again, because as you can see, we have defined report alarm as first send an email and then send a notification. So first another email will be sent and then the event will be reported to the ARC through the gateway, to the V4 gateway. If you manage to do something like this, you could also erase the the drawing I have already made. Okay, so as you can see, we could define a lot of zones and a lot of rules. There is no limit in the number of zones and the number of rules you could make for one scene, but we always recommend to keep it simple because in our experience, when the configuration is simple, it not only behaves better, but the maintenance of the system, especially if the people maintaining the system is different from the people that configured it, it's easier for them to maintain the system. This is why we always recommend configuring meaning names and also keeping the configuration simple. Another thing we could also configure. Let me delete this one. We have yes, this one. So let's only maintain the immediate. Okay. Another thing we maybe is useful is the dependencies. Let's imagine a situation in which we want to detect a person moving through one zone to the other, and we only want to report to do something when someone passes from one to the other. Okay, so let's configure it. In this case, we, for example, we want to configure an immediate triggering in the green zone, and we will also configure an immediate triggering $, people on cars, an immediate triggering in the red zone. Okay, so we have, let me also, so names always. So we will add a dependency and the system will ask us origin. Okay, as you can see, the dependencies are directional. If we want to perform this configuration bidirectionally, we will need to add two dependencies, one in one direction and one in the other direction. So name dependency, okay, origin, far zone, immediate, destination, near zone, immediate. And what we want to do, we want to report the alarm. Okay, so the dependency is set. But we have done something terribly wrong. Let's think as we were the system. Someone gets here, enters the green zone, so this rule is triggered, so an email is sent. Then we walk, we cross the zone to the other. So the red zone is triggered. So an email is sent and a report is also sent. And then the dependency, as we have an alert in the red, in the green, and then in the red, another email is sent and another alarm is reported. So we have done the things, multiple times. So if we set a dependency, we need to ignore the other alarms, because in other way we will do more than once. We will report even more than once. So let's think as we word the system again. Someone comes from here, enters the green zone. Well, this rule is triggered. We do nothing, just know that this has been triggered, but we do nothing. Then go to the other zone. This other rule is triggered. Do nothing, and then the dependency is triggered. We compiled first with this rule, then we compile with this other rule. So we report an alarm, so an email is sent, and the event is reported to the ARC, but only once. So these kind of things are important because there are situations in which, for example, you could use this first rule to do something. For example, instead of sending an email, you could, for example, let's see, you could light. For example, enable a light. You could do so. So in this case, you will need to go to IO and activate an output. As we don't have any IO device added to the system, I cannot add an action to the alert. But let's imagine that we have configured this properly, and if this alert is triggered light, a light is enabled, a surprising light is enabled. So we could, for example, define the far zone alert. Instead to ignore this alert, we could have defined it as light. So for example, someone comes here, enters the green zone, this rule is triggered, a light is enabled, people get surprised and run away the scene. So all these kind of situations could be configured using multiple rules per zone and multiple dependencies and that kind of things. As you may also know, these kind of configurations, as you can see, can be time consuming if you are not used to performing these kind of situations. But as you also as you can see, they are very, very powerful because you have all the tools to configure them properly and to adapt to any possible configuration you have. We also have this check black image. This is important because this will detect if, for example, if we, as I have already said, a very usual situation is that we are asking for the video to a DVR and not to the camera. So if we cut the communication between the DVR and our system, an alert of signal loss will be triggered. But if we, in this kind of configurations, cut the communication between the DVR and the cameras, the DVR will we already have communication with the DVR, so a signal loss alert will not be triggered because we have this communication enabled. So uh, just a black image will be sent to us. So if check black image is checked, we will detect this situation and trigger a black image alert for you to know that the DVR is giving us a plain image. It's not strictly black because in some DVRs or devices, this is not strictly black. black, but a plain image with no information. This is other security measure we have implemented in the system just to be more reliable. And the only thing I have left to speak about is the region of interest. As some cameras and DVRs let the user define masking zones in which the video is black, just to avoid recording some areas of the screen for legal issues or any other matter. We have region of interest. You could in a scene like this define a region of interest. For example, let's define this region of interest. To define a region of interest, we could just define it as we were defining a zone. For example, let's see that we want this. So we mark the thing that we want to analyze. Is the opposite of a masking zone. When you define a masking zone, you're defining the thing you don't want. In a region of interest, we define the thing that we do want to perform any analysis in. So instead of clicking on create zone, I will click on region of interest, and some part of the image will get masked in blue. Everything masked in blue will not get detected, will not get processed by the system. This is useful, for example, to avoid processing, for example, these kind of things like trees or vegetation that could potentially cause false activations. So it's really useful. For example, street lights and that kind of things. But this not work in a camera because everything masked in blue will still be recorded. The only thing is that everything masked will not be detected in, but it will be indeed recorded. And when defining region of interests zone, only one region of interest can be defined by video source. This is important to know. And the other thing that is really important to know regarding a region of interests is that when defining a region like this, it could cause the object to be cut down. For example, let's imagine that a person is sitting right here. As I have said, you could define a minimum size for an object, and more or less this object will be detected if we adjust, for example. Okay, this person will be detected because it's bigger than the minimum size. This is what we could think. But as I have said, um, everything masked in blue will not get detected. So the system will not see the complete person there. It could see something like that. So it could be not bigger than the minimum size and it could be not detected. So the proper way to define this region of interest is, if you click again in raw, the region of interest get deleted and you could just redefine it. So the correct way to define this region of interest will be, for example, doing something like so, in which we get space for an object to be completely recognized, and if someone now stays here, it could be not cut, and this size will be correctly calculated for the for this rule to be properly triggered. In the case of region of interest, we only recommend setting region of interest in scenes in which we are having trouble with the detections for false activations and that kind of things. In a easy scene like this, we will not recommend using the region of interest and just setting a normal configuration. And more or less, I think I have in the time we have explained more or less everything you need to know to do a basic installation. We also recommend just reading the tutorials and the guides we have on how to do all this I have explained. And if you have any doubts, as always, you could count on us and ask any question you have. And I really wish that this explanation has helped you to know what tools we have and what are the advantages and the disadvantages of this system. What is the selling points are the differentiation of this system from others. And of course, if I have answered the questions you may have. So if you have any other question, we can answer it now.
Well, for now it's quite clear as always. The doubts came later. I don't know if my
Yeah,
colleagues
yeah.
have something to ask. Let's see. For my part, it's quite cool. Okay. Thank you very much for your attention. And if you please, if you can send us the recording of the training and the presentation, we appreciate it.
Okay, so I will ask my colleagues, and I think it would be no problem in sharing that with you.